What is a mole? Well, to a chemist, it's a unit of measurement. And it's a pretty big unit. Unlike a pair, which is only 2 items, or a dozen, which is only 12, 1 mole equals 6.02 times 10 to the 23rd items. So who came up with the unit, the mole? It was a scientist whose name was Avogadro. So why did he come up with this unit? We need a way to figure out how many particles are in a sample without directly counting them. Atoms are so tiny, it's impossible to figure out how many you have using the naked eye. So Avogadro came up with a mole and related it to the mass of the sample so that we can figure out how many atoms we have by using a scale and measuring the mass in grams. The first mole equation is big N equals little n times Na, where big N stands for how many particles you have, little n stands for moles, and Na stands for Avogadro's number. The second mole equation is little m equals n times big M, where little m stands for the mass of the sample in grams, little n for moles, and big M for molar mass, which is how many grams does 1 mole of your sample weigh. Here are some examples using these two equations. How many moles are there in 5.39 times 10 to the 24 molecules? In order to answer this question, I'm going to use equation number 1, but I have to rearrange it for little n. If I do that, if I take my particles and divide it by Avogadro's number, that will get me moles. I always suggest that you follow through with your units and include them in all the math that you're doing. That way you know that you've rearranged an equation correctly. Here I've got molecules divided by molecules, so that cancels out, and the only unit left I'm with is moles, which is what the question asked me. So I know I have the correct mass solution. For the second example, what mass does 1.5 moles of CO2 weigh? Well, I'll have to use the second equation for that, and I'm going to be solving for little m, mass in grams. So if I take my 1.5 moles of CO2 and multiply it by the molar mass of CO2, which I get by adding the mass of 1 carbon and 2 oxygens together, that gives me how many grams my sample is. Remember, follow your sig-dig rules. I have 2 digits in my 1.5, so I can only have 2 sig-digs in my answer. To change information from one unit to another, or from one chemical into another, use a conversion factor. Start by writing down the number that you're given, then times it by what you want, and divide it by what you already have. Here's an example. How many hydroxide ions are in 3.3 times 10 to the 12 formula units of magnesium hydroxide? So I start by writing down the number that I'm given, and then I times it by what I want, hydroxide ions, and divide it by what I already have, magnesium hydroxides. I figure out the numbers for my conversion factor by looking at this formula. Because I'm not doing a chemical reaction, I look at the magnesium hydroxide formula and ask myself, how many hydroxides are there for every one of those formula units? And there's 2. So my conversion factor becomes 2/1. Conversion factors work out nicely, especially if you put your units in and keep track of them. If you've set them up correctly, your units will cancel out, and you'll be left in the unit that the question asks you about. So now if I take 3.3 times 10 to the 12, times it by 2 and divide it by 1, that gives me 6.6 times 10 to the 12. The only unit I'm left with is hydroxide ions.